Hello, welcome to the Maya Toolbelt. This is Michael. Today we're going to talk about smooth. The smooth command can be found in the polygons menu under mesh, smooth, right here. If you go look in the options, we have several settings that we'll be looking at today. We have two different types of smooth. There's exponential smooth and linear smooth, which we can switch between here. They both essentially do the same thing. It's just that the two different types of smooth options have different controls. So depending on how you're trying to smooth an object can depend on which type of smooth you'll want to use. And we'll go over all these options. Go to Edit, Reset Settings. You see our default smooth setting is set on Exponential Smooth. So we'll go over that first. Before we go too much further, let's first create an object to smooth. We'll go to Create, Polygon Primitives, Cube. Make a cube here. And with all the default settings, I'll just hit Apply. And you'll see what happens is it subdivides the mesh and creates a smooth object, or smoother object. Now you'll see it's still pretty chunky looking. It's not exactly a round surface or round ball or very smooth at all. It's just smoother than it was. If we go over here to the channel box under the Poly Smooth Face 1 input option, we have the divisions setting, which is by default set to 1. If we increase this, it will kind of compound the smooth so that with a division set higher than 1, it's kind of redoing the smooth again on top of the object. So if I did a 2, for example, it smooths it even further. We can go up to 3 and so on, and you'll see how the object increases in density but also increases in how smooth it is. So this cube we started with has become much smoother and pretty much a ball. So let's undo that. Let's go back to before the smooth took place. Like so. So here's our cube. Now in case you didn't want a ball out of your cube, you just wanted your cube to look like a softer or a smoother cube, the way you can achieve that is by adding subdivisions on your edges so that there's more detail there. So for example, if we just select our entire cube and go to Edit Mesh, Bevel, and in the bevel options I'll decrease the offset so it's not quite so high. So now you'll see each edge of the cube is beveled and has this extra lip of geometry. So if we apply the smooth now, we get a different result. Mesh, smooth. So you'll see now it's much more cube shaped. So if we increase our divisions, you see as we get higher and higher, we maintain that more cubular shape. So by increasing the divisions along the edges of that original object, we maintain that original shape better than if we didn't. Without doing that, the cube essentially became a sphere. Keep that in mind if you notice that your object has become far too smooth. You can increase divisions, you can add bevels to edges, and so on. Because of history, I can go back to my bevel in the channel box here and increase or decrease its offset, and the smooth result will change based on that. And it pops to 0. It means my bevel is no longer taking effect, so it becomes that sphere again. But if we change our offset of our bevel to a very small value, you'll see what we get here. If we decrease, or I should say change that offset to be much different, you'll see we get much different results. And if we were to decrease our divisions back down, our smoothness will get not as smooth. If we take our divisions back down all the way to 0, it's as if you're turning the smooth off and you're back to your original object. And this is with our offset cube here, like so. So let's go back to our smooth settings and take a look at all the options we have available. So first, looking at the exponential controls, we have our division levels, which we've already touched. Then we have continuity, which is a slider from 0 to 1. And we have some checkboxes here. We have smooth UVs, which we'll get to in a minute. Propagate edge hardness, which is a checkbox which is turned off by default. We have map borders, and map borders is referring to UV maps. And then we have some checkboxes for preserving things. And by default, preserving geometry borders, selection borders, and tessellation is all turned on, and hard edges is turned off. So since we already have a smooth applied, right now this division says 0, so it's turned off. We can look at these options in our cube by adjusting them here in the channel box. So let me increase my divisions up to 1, which turns my smooth on. Actually, let's do 2. Another thing you'll notice in the channel box, there is no separation between exponential and linear controls. Down here under the linear controls section, there's these options for roundness, push strength, and so forth. And in the channel box, you'll see down here roundness, push strength, these options that are associated with the linear smooth control as opposed to the exponential control. And even though our method here in the channel box is set to exponential, these settings are still visible. So keep that in mind, that these settings, if I were to adjust the roundness, nothing's going to happen because we're using exponential as the smooth method instead of linear. So these linear controls are going to show up in the channel box. Just have to keep that in mind and just know that they won't do anything unless your method is set to linear. So if I change it to linear, as you see here, the object changes obviously, and all the controls for exponential are also visible and also will not have any effect while linear is active. But let's go back to exponential. So continuity, if I were to decrease this value from 1, you'll notice the change in the geometry. The number of divisions stays the same. It's not changing how much the object has been subdivided, but it is kind of going back to the original shape of the cube. So it's as if with the continuity of 0, it's as if the object has not been smoothed at all. It's just been subdivided. As we increase our continuity up to 1, this is at the maximum smoothness, you might say. So if you smooth your object and you think that the corners are too rounded, you can adjust your continuity a little bit and get maybe a little bit sharper corners for the cube that you might want. And if we take our continuity back up to 1, you'll see that our corners on this cube are much softer. For smooth UVs, we'll get back to that later. I think we're going to go through all the geometry stuff and then we'll go back and look at the UV stuff. So propagate edge hardness is turned off, and you won't really see it in the channel box here. One way we can get to that after applying the smooth as we have is by hitting Control A and opening the attributes. Look at the Poly Smooth Face 1 tab in the attribute editor, and here we'll see a checkbox for Propagate Edge Hardness. So if I were to check this box, we would turn it on, and we'll look at our object and see if there's any change. In this case, not much of one. However, if we decrease our continuity, you can see the change much more evidently. So here, with our continuity down all the way to 0, so our cube shape has been retained, you'll see that these edges here along the corners are much sharper than they were before. If I uncheck Propagate Edge Hardness, you'll see now those edges are much softer. we increase our continuity a little bit, you see and then propagate edge hardness, you can again see those hard lines where those hard edges in our original cube were located. With continuity all the way up, those hard lines have moved up here and are no longer as visible. So keep that in mind. If you turn that on and don't see a change, you might need to adjust your continuity a bit to see the change appear. You can see here that it's starting to become more visible with a continuity of around 0.4. And as I decrease this down further, the effect of propagating the edge hardness from the original cube is much more evident. That's propagate edge hardness. That's the edges that you've smoothed from the original cube that were hard are maintaining that hardness in the smooth result. So matte borders, again, is referring to UVs. We'll get back to that in a minute. Now let's go to the preserve checkboxes. By default, we're preserving geometry borders, selection borders, and tessellation, and not preserving hard edges. Now, propagating hard edges and then preserving hard edges, which these are these two options here, they're very similar but different. The propagate edge hardness is making those edges that were in the original cube that were hard and keeping them hard after the smooth has happened. If we preserve hard edges, you'll see that no matter what my continuity is, see, continuity has essentially no effect. It's maintaining that shape from the original cube where those hard edges were located. So preserving the hard edges keeps those hard edges in place. It doesn't change their position. If we turn off preserve hard edges, you'll see all those edges move because they become softened. Another way to show preserve hard edges is I'll make a new cube. And this time, before applying the smooth, I'll select the top edges of this cube up here, go to Normals, Soften Edge, like so. So these edges have become softened before the preserve, or before the smooth has taken place, while these down here have been maintained hard edges. So Mesh, Smooth, increase my divisions to 2, like so. So we still have the same overall result, but this time I'm going to, in the channel box, say keep hard edge, turn that on, and you'll notice it's a little bit different now. The hard edges down here at the bottom of the cube have been maintained, but the top of the cube, and it's getting very funky because we have hard edges that were adjacent to soft edges, so we're getting a bit of weirdness. So keep that in mind when you're dealing with this command. But you'll see that the top edges have tried to maintain the smooth effect, while the bottom edges have maintained their hard effect. Okay, so that's maintaining those hard edges. And so before, like I said, geometry borders and selection borders are also maintained, as well as tessellation. Now, selection borders and geometry borders, what that's referring to is whenever you smooth a partial object. So let's actually delete this cube, and let's get a sphere. Create polygon sphere. And I'm going to decrease the subdivisions here so the sphere doesn't start quite so smooth already. So you have something like this. I'm going to go ahead and soften the normals, like so. So now I'm going to select the top half of this sphere and apply a smooth. So we're going to Mesh, Smooth. So you see only the top of the sphere is getting the smooth effect. And I increased the divisions to 2, so it's a bit more dramatic. So this bottom half is still maintaining this hard or low subdivisional look, while the top half of the sphere has become much more dense and smooth. So because we smooth a partial object, we have a selection border. The top half has been selected to be smoothed, while the bottom half has not. So if we go back to our smooth channel options here, and keep border and keep selection border, when in the channel box here, keep selection border is referring to geometry selection, and then keep border is the same as keep or preserve geometry border. So there's selection border over here is called keep selection border, and geometry border over here is just called keep border. So right now we're looking at a selection border. If we keep selection border, right now it's turned on. Let's turn it off. You'll see what happens is now that chunkiness that was there has become smoothed away. So if you're keeping the selection border, you're maintaining this shape here around where the original cube started at the border of our selection. If we keep that selection border, it keeps that shape here. If we turn that off, it makes it rounded as well. And for a geometry border, what we actually need to do is I'll create or undo that before the smooth. We have our original sphere here. I'm actually going to select the bottom half and delete it. So now we have a geometry border here at the edge where the object becomes open. So I will smooth this object now. Mesh smooth. Increase my divisions to 2 again. So now we have keep border, which is the preserve geometry border option, and it's turned on. And again, you'll see at the edge of our object, we still have that profile shape from the original low resolution sphere. So we keep border and turn that off, it smooths that out. It doesn't maintain that border position. So if you were to adjust those, turn these on and off without having those borders available, there was no selection border, there was no geometry border, even though you can turn them on and off, nothing would happen. And then keeping tessellation. When changes are made to the history, it won't redo the tessellation, it'll just maintain it and reposition vertices. So now let's go back to the UV options. We have our smooth UVs, which is turned on, and then map borders, which is smooth all, smooth internal, or do not smooth. First, let's take a look at the UV texture editor. What I like to do is over here on the side, I like to make a button. If I right click one of these window layout buttons, you see there's perspective UV texture editor right here. I click that. We have our perspective view on the left and my UV texture editor on the right. So with our for each primitive that we make, let me delete this sphere. If we go to create a polygon sphere or create polygon cube, you'll see over here on the right, these are the UV layouts of these two objects. This is the sphere and this is the cube, and these are the default UV layouts. These can be changed based on your needs, and we'll get into editing UVs more thoroughly in other videos. But just know that these are the UV coordinates for texture placement on these two objects. And what this option here for smooth UVs is for is that whenever your object becomes smoothed, will your UVs also smooth as well. So I'm going to apply that bevel to my cube, edit mesh bevel, change the offset a bit, and you can see what happens to the UVs as I do these things. And now let's apply the smooth. And the options, again, we're going to go to edit, reset. I'll increase my divisions to 2. Smooth UVs is turned on. It's smooth. So you see over here in the UV texture editor what happens to the UVs. They become subdivided just like the original object. But now over here, let's turn smooth UVs off and see what happens. You see how it goes back to its original sharp edged position, and not instead of the smoother position after with smooth UVs turned on. So Let me undo the smooth. So this is before the smooth is applied. You see how the edges are laid out here in the UV texture editor. We'll apply the smooth. This is with smooth UVs turned on. You see these edges become a little bit softer, these corners, and the geometry has been kind of pushed around a little bit with these curves. And we turn smooth UVs off. And now they're back to their hard edges and maintaining that original position. Let's go back to our options, mesh, smooth options. So that's smooth UVs turning on and off. There's also map borders, smooth all, smooth internal, or do not smooth. And you can see this after applying the smooth in the attribute editor. Control A. Scroll down, we have preserve map borders. First, we have to turn smooth UVs on for this to have any effect. And preserve map borders right now is internal. If we choose none, you'll see the UVs, how it really changes. The UV map borders become smooth as well, as opposed to just the internal UVs within those borders. And then we have all, which in this case doesn't really do much. But between none and internal, you see a big difference. And in my opinion, actually, choosing none gets a bit of a cleaner result. You see with only internal UVs, we have these kind of bowing UV coordinate placements, all these curves here with pinching right here, and it's not very uniform. If you go to preserve map borders being none, it's much more uniform and more in line with what is actually there. So it just depends on what your needs are for your project. That's all the exponential controls, or options I should say, under the smooth options box. Let's look at linear now. So linear, we have much fewer options to choose from. We have division levels, which is the same as division levels up here, increasing that to 1 or 2 or higher. Divisions per face, push strength, and roundness. So let's quickly go over those. Over here for method, I'll choose linear. So now you see a much different result. This divisions option here is set for the exponential controls, while down here we have subdivision levels for linear controls. So these 4 options down here in the bottom of the channel box are for linear smooth, and all these above that are for exponential. So keep that in mind when you're trying to deal with linear. The divisions command, the divisions option up here is not for linear. You'll need to use subdivision levels instead. But it essentially does the same thing, where it increases the density of the smooth object as we increase subdivision levels. You'll notice a difference in the pattern of how the subdivision takes place. We get this concentration of triangles in our geometry around here and around the corners. Let's go back to our options here. So division levels is how much subdividing we're getting, and over here it's called subdivision levels. Then we have divisions by per face is 1. So for each face in the original cube, we're dividing it once. However, because our subdivision levels is to 4, we're compounding that 4 times. So we're applying the smooth 4 times with 1 division per edge times 4. So let's take the subdivision levels down to 1 to keep it a little bit easier to understand, and increase our divisions per edge up, and you'll see the result we get. So that's increasing it to the default max of 4. You see we have this result, and now we can increase our subdivision levels up higher, which is much more dense with a subdivision level of 2 than it was before. So divisions per edge is 4. Take it as 0. You see with divisions per edge of 0, we get the original shape. Increase this back up to 1, and with a subdivision level of 2, we get this result. So it's kind of a balance between these 2 settings to get the kind of smoothness and density that you want. Push strength by default at 0.1. So let's increase these values, and you see the result of what happens. It's pushing this geometry further And we can get some interesting results, like so. So it kind of increases the volume of the object with the push strength. And we can go negative. So this is typing in negative 0.5. We get this result. But by default it goes to 0. So for those negative values you have to put them in manually by typing them in. And then roundness. But roundness will kind of create a little bit of a bulge in our object, and it might help with push strength. There we go. You can see more of that bulge happening with a higher push strength. So definitely different controls for a linear smooth as opposed to exponential. Exponential is much more what I would call straightforward, where you're just applying a smooth to your object to smooth the geometry as it is, while the linear smooth gives you these kind of a little bit more unusual settings for roundness, giving you this bulge effect and push strength, which you don't find in the exponential settings. Let's go back to exponential real quick. Here we go. One thing I want to make sure you understand is with exponential smooth, with the default smooth settings, Maya will try to do its best to maintain quads in its geometry, which is easy to do in this case since our original geometry only had quads. And by quads I mean four-sided faces, these square shapes. But let me delete this and let's create a new object. Let's do a sphere. So right now the sphere has square faces everywhere except at the pole. You'll see here at the pole it has these triangle faces. So if we apply a smooth, go to Mesh, Smooth, and then look at the poles. You see what a little bit of funkiness here, kind of a star pattern. And the reason why is because it wants to create four-sided faces. And you'll see that these triangles now have these extra points in them to create four-sided faces. If you look at this one in particular, just for example, while it looks very arrow-shaped, it does have four sides. We've got 1, 2, 3, 4. So any geometry that you have in your object that is not four-sided will get this kind of result. So keep that in mind. If you have a lot of triangles in your geometry, smooth might make a bit of an ugly result. If we were to, say, mesh triangulate this sphere, so now it's all made of triangles, and then apply a smooth to it, you see we get this result, which is a bit more interesting looking, but not exactly clean geometry, because it's trying to maintain four-sided faces after applying a smooth. And so because it was all made up of triangles, we get this kind of very funky result. So whenever you're using a smooth, you want to try and keep your object composed of as many quads or four-sided faces as possible to get a clean result. It does get smoothed, don't get me wrong, but when I let go of it and not have it selected, you can kind of see the surface is kind of dimpled and has these little odd, little subtle ridges all through it because the geometry isn't exactly clean. So keep that in mind when dealing with smooth. But I think I touched everything. I hope you enjoyed the video and learned a lot about the smooth option or smooth command. If you have any other questions or if I missed something, definitely let me know. If you have any requests for future videos, please do so. I'll get to them as soon as I can. So thanks for watching, and I'll talk to you later.